So I guess we can start. So some main thing first is please fill in this, and then I will try to do the lottery, decide who get the priority first, and then I will calculate later, tell you whether I can allow you to take it. Okay, because I have to count the time constraint and decide whether I can accommodate. Okay, but we'll do the lottery at the end after the first break. Okay. So let me talk about the lesson 3. We'll finish this set of slides. And as we said, I think at 9 o'clock we have a quiz. Okay. And then for those of you who study well, once you're done, if you want to leave, you can leave early. That I fulfill what you want. But I will be here until 9:30. Okay. So let's get started. If you notice the blackboard, you see it is a rare case I update my slide because I noticed that some of you don't understand some material. So I add a few slides there. Okay. Usually I don't change slides. Once I put a slide in the semester beginning, I never change. But this time I noticed there's sufficient number of people that are asking the question, so I decided I add the slide and rewrite it because I feel like you need to have that. So let me see what I changed in the slide. Okay. So this is something I think it's okay. No one will have problem with this one. Okay. So the question lies on interval estimate, right? For point estimate, we want to estimate the mean, right? That is very simple. We just use the sample mean, right? In the data here is we want to estimate percentage of day more than 5% loss is the measure of risk. How do we do the point estimate? It's actually, you can look at data, actually how many days in proportion are more than 5% loss, right? And you look at data out of 2,500 days, right? You have 0.5 percentage of day, right? That will be your point estimate, right? This is what you guess. There's a single guess. If you're the guess, this is a number, okay? And now the problem is the sample mean is a random variable, depending on what sample you're drawing, okay? So you want to quantify that, you want to know the standard deviation of this sample mean. Let me repeat. The sample mean is a random variable. It depends on what sample you're drawing, okay? So this itself, I want to know how good it is I need to know its standard deviation, okay? And usually we call, this is called the standard error of the mean, okay? And according to math, I don't want to bother you, but you can check your undergraduate slides, okay? The standard error, which is the standard deviation of this sample mean, right? Because it depends on which sample you draw, right? Is equal to the standard deviation of the original data divided by root n. Okay, let me draw a picture to explain this to make sure you understand what's going on. Okay, imagine in this world, okay, in the population, you have Mr. 1, Mr. 2, right? And say Miss 3, Miss 4, so and so forth, right? And you have many people there, right? And then if you calculate this data, you can't look at the whole data set, right? So you would be going to some sample, right? And depending on what you draw, right? Suppose you draw these two guys. Okay. Okay. Then you calculate sample mean. Then you get 2, right? If you are drawing this guy, the sample mean will be 3, right? If you happen to draw this guy, right, the sample mean is 1.5, right? So it depends on the sample mean. It's a random variable. Depend on which sample you got. The question will be, what is standard deviation of the sample mean, right? That means that if you draw many sample mean, keep drawing this. What is the standard deviation, right? Because what is variance? Because you will have many sample mean, right? Potentially, you can draw many times, and then what is the standard deviation of this, right? And turn out to be this sample mean will be, if you calculate the overall standard deviation is sigma, right? And turn out to be the sample mean, the variance really depends on the sample size, will be this over root n. Why? It's very simple. Think about this. If your n is just one guy, the standard deviation of the sample mean just same original, because you just draw one every time you draw one guy, same as you just close your eye, draw it, right? When n is super large, say when n is very large, you just keep drawing. Then basically you get everyone there, right? So then every time you get everyone, then there's no variation. This go to 0. The variation of sample mean will be 0 if you draw super large sample every time, right? So that's why this is called the standard error. It's SEM, right? So that means that this is the slide right here, right? So if you have this, right, we replace by standard deviation. This is what we have. This is the code in the Python, right? So that's why we have that. Okay, this is the first part. Is you have the point estimate, and you want to look at how good the point estimate. Look at standard deviation of the sample mean. Okay, that is very simple. Okay, and now come the second part. Is if we just not only satisfied with single 1 point, we want to estimate more than 1 point. Okay, interval. You want to tell me lower bound, upper bound. Okay, and usually we want it to be 95%. You can 99 or 90 is fine, right? And turn out, okay, if there's a bell curve, which apply in our application anyway, okay, in many cases, turn out to be, if you want 95% confidence, is add and subtract to SE, okay, and SE the standard deviation of this sample mean there, right? Why? Because a bell curve, right? You would plus and minus 2 SD of the distribution of that is 95% will fall be within that one. Okay, this is what you learned undergrad. Okay, nothing new there. The only thing to remind you is this is the standard deviation of this guy. Turn out to be from data will be sigma over root n, right? Because the larger sample size, the standard deviation sample mean will be very small, right? If you get a smaller data set, then the variance is larger. So you have to be over root n. Okay, so that's why you have this formula, right? Okay, this is, remember what this is estimating the population variance, right? Population standard deviation. But you're talking about the sample mean, then you have to divide it by root n to get it, right? Remember, this is estimating the variation of the population, right? But you are not talking about the various population. You're talking about the variation of your sample mean. Okay, that will be inversely related to the sample size. The larger sample size, it gets smaller. So you have this guy. So I think many of you are confused why we have to divide by root n, and why when you do simulation you don't do the root n. Okay, remember this is capturing the standard deviation of the sample mean. Okay, remember this statement. Now go into here, right? That's how you calculate the formula there, right? This is W root n, right? And now this is the calculation I'm not going to repeat, but now I'm not going to talk about the simulation, right? Why you do simulation? It's because of you don't think the bell curve is good first, right? And also the bell curve would not fit for many cases, right? If you don't think you don't have a large sample size, then you have some problem, okay? So how are you going to estimate those? Okay, remember what we're trying to get here is I want to do this, right? I look at the variation of the sample mean. So I just create a history, okay? And I pretend there are many samples there, right? So what I'm doing is I try to pretend this is going to happen. I create many of these samples, right? And have many sample mean, right? And this sample mean, right? The standard deviation will be my estimate of SE. How I create this is artificially from the data, create many of this. Okay, let me go to the slides again. Okay, so there are two ways, right? One is called resampling, one is called bootstrapping. And I call resampling because this is what the book tells us. But if you look at other texts, they will call subsampling. Okay, but I follow the book, so I do that. But next year I will call subsampling because I think it's better to follow what people call in the lecture than the book. Okay, so what people in the industry than follow the book. But anyway, this is what the book said. Okay, well, the difference is one is without some replacement, one is replacement. I think many of you would confuse, so that's why I make this. Okay, remember, you still want to estimate the standard deviation of this guy. Okay, so the idea would be you do it without replacement. Okay, so let me look at picture. I add a picture here. This is what it is. Okay, this new picture I add is I have 5 different balls. You can have more, but it's simple. 5 balls there. Okay, for resampling, we are not going to reconstruct the same exact sample size. This we do in the bootstrap. Instead, we're doing much smaller sample. Okay, and I do in the way that I sample without replacement. So there are no number that repeat themselves. Okay, I take a number 1. You see it? I forget it. I take another number 3. I forget number 2. So there's no repeat. So that's called sample. I don't take repeat. Okay. And once over that, I would have sample mean for each one. Right? And then the next step is I calculate the standard deviation of this mean that gives me the standard error, because I want to know the variation of the sample mean, right? Of course, I can use the formula, but I don't want a formula. I use this one. Right? When we create many universe, right? Each universe I have sample mean, and each universe, different universe, the sample mean, the variation, give me the standard error. Okay, the standard deviation. Okay, standard deviation of this sample means. So that's how I create this thing, and that's how the Python code goes, right? That's what the Python code is, right? Just to repeat, because I think the Python code is good, right? I have 1,000 samples. Okay, each one so 10,000 samples. I have 1,000 observation. So that means that I have 10,000 here. Each one is 1,000. Okay, and this is 2,517. Okay, so that's how I do the calculation in the Python code, right? So we start a random seed here. I start the resampling. What I do is, okay, for each data, right, I take out 1,000 observation, 1,000 days, right? 2,000 days, I take 1,000 days, but without replacement. So I take 1,000 days, there's no overlapping days. Okay, and in this, okay, one sample, I calculate the sample mean, right? I store it. But I repeat this for 10,000, okay? I have 10,000 sample mean. For this 10,000 sample mean, I can get how the sample mean changes, because the 10,000 case, I can see whether they are concentrated or separate. If they're very concentrated, my standard error is very small. If they're very spread, the standard error is very large. And that will quantify how good is our sample mean. Okay? And that's the idea behind why we want to do this. That's why I'll calculate this as standard. That's why it's called standard deviation, right? Because we exactly calculate the standard error by pretending the process of collecting data. Okay. And just to emphasize, the reason why this works is we believe our data is representative. Okay. If not, doing this process is completely wrong, right? You have to make sure that this is the right thing. Okay. And if this is not right, you have the problem. Okay. So that is very important. Is assuming our data is a good enough, okay, representative enough, then your process of doing this pretending multiple universe works. Okay. If this is a garbage, of course, garbage in, garbage out. Okay. So that is the idea behind. Okay. So I don't need to assume a lot of things there. And some of you actually also ask me, that's it? Is it we just use this sample mean and just end of the story? No, we can do more things, but in our class, we just make it easy. Okay. But some of you will say, okay, this is still assuming one thing. Some of you actually, okay. Why I have to add a -2? Because add and -2 only hold for bell curve, right? This is the normal distribution tell us the bell curve would say 95% is within 2 SE, okay, standard deviation. But may not be bell curve, right? So why you have to do 2 SE idea? Yes, you don't have to do that. Indeed, it's actually more advanced. Will be instead of looking at 95% is symmetric. You look at the bottom 2.5 as a cutoff point and 97.5. Okay, let me draw a picture to show you what I meant. Okay, so if you have the bell curve, okay, if the bell curve, okay, if this is the mean, right, bell curve, right, you go left by 2 SD, right, and go right by 2 SD, right, and we learned that this area is 95%, right? This is always hold for the bell curve. That's underline what we have done so far, right? All the analysis is bell curve, go left by 2 SD, go right by 2 SD, you include 95% of everything, okay? But, well, you may not have this nice shape, right? So suppose the data is like this, it's like, ooh, yeah, whatever, right? You can do whatever like this, right? Can be anything, right? Then what we're going to do, then you will be doing this. Looking at the data, look at the left-hand side, look at 2.5%, right? And look at the right-hand side, also 2.5%, right? And the middle will be the range you want to guess, right? Then you allow any shape you want. You can be asymmetric, doesn't really matter anyway. So you will be the range you're going to guess, okay? So that's why it's 2.5 percentile and 97.5 percentile. So this is more hardcore if you want, right? But for our class, we just make it simple. Just follow the symmetric idea, okay? As long as it's not too deviate from normal, what we do in the class will be fine, okay? And this also taught in the book only, okay? And some of you actually asked me, okay? So that's why I want to mention, right? Bootstrap is, or resampling is way more convenient than you think because you actually get the data. You simulate, pretend the data there. So you can do way more than this, okay? And also you can way more than mean, right? You can get whatever you want to get using simulation. You want to care about median, you care about mode, you care about whatever quantity you like to care. You can always do this as an estimate and always can do this idea, okay? So there's no limit to what you want to do, okay? The sky is a limit, right? So the computational power is a limit. Otherwise, you can do whatever you like, okay? So that is the thing. And the next thing I want to work you out again is the bootstrapping. I also changed this. It is just try to be consistent. Is bootstrapping require you to recreate the same length of the original one. Okay, but of course, in that case, you must allow repeat. Otherwise, every time the same thing, right? So that's why you would allow you have 2, 1, the same thing, right? 3, 3, the same, 4, 4, the same. Or 2, 2, you can be repeat yourself because depending on how you draw. Okay. And this is called bootstrapping. The rest are the same, right? The rest are the same. Only the first step is different. The bootstrapping and the subsampling or resampling are the same thing. Okay. It depends on the first you draw. Okay. And some of you actually ask, I repeat again, is when you use what? Okay. Bootstrapping is more common. Okay. But the problem of bootstrapping is what happens if you have 1 billion, 1 trillion data, then you calculate this, then your computer will probably die. Okay. Or you just consume too much computing power. Okay. And in that case, the method we mentioned previously will be better. Right? Then you have a somewhat much faster calculation. And also there is some issue if this data has some relation, there's some structure, it's not random sample. Okay, then in that case it's not that good. Okay, especially for our stock market data, you imagine that today's price and yesterday's price can be related. Okay, and in that case, the resampling is better because it keeps some structure of the data. If you do this, actually you break some structure. Okay, so and again, for your application, I don't think this will matter that much for IT application, unless you're talking about your data has very high frequency and then things are related, then probably you have to worry too much about that, right? Or your data has combining, say, 1, 2, 3 is the data from Shenzhen and 4 and 5 from Hong Kong, then probably have to a little bit careful with how you do the bootstrapping, right? But otherwise, I don't think that's a big deal for your, so most of the application doesn't really matter. Okay, but that would be the idea. Okay, the difference is only difference for our application is this is true, right? And this observation is the length of original data. So only this line and this line, this one is the difference between the two cases. And that you do when you do an assignment, you know, right? There's only 2 difference. Otherwise, things will be the same. Okay. Is there any question? If you do, let me know, because I think that when you know there's a problem when you do assignment. Okay, the assignment is not difficult. I mean, I have asked TA to see if AI can do it. He said yes, can be done. So and done perfectly. So you can pretty much try to see if you do it right. But I recommend you not to pick the answer first, right? Try to do it by yourself, because I think it's very obvious from your slides. Okay, many things is not too difficult. Okay, but it's up to you. Okay, I can't force you to do anything, right? Because it's very hard to make the assignment that is not doable by AI, right? So that would be the thing we cover. And now we go to hypothesis testing. Okay, so I hope this review will help you to do the assignment better. Okay, and hypothesis testing is not in the assignment, but I want to finish it, and then we go to the regression. Okay, which have more fun. Okay, so I changed some of the slide because because I noticed that many of you actually forget about hypothesis testing. So I start from the beginning, hopefully make it easier. Okay, if it's more difficult, let me know. I change it back. So hopefully easier. So hypothesis testing is you have some idea about the big picture. You want to use data to validate. Okay, it's a validation process. Okay, you don't test it. So as I said, you have some idea about some statistics called S, likely sample population mean. Okay, you want to see whether this true value is supported by your data, right? If your data is exactly this value, then you're done, right? But it's different from that, then is it going to say something? Is it different enough, right? Because you always do some sampling. It can't, even though it's true, it can't have the same number, right? So it depends on where you draw, right? So what I do is I would try to use the courtroom cases, right, to make the analog, right, because we're law school at the next door, so I think it's a good example. Okay, so here in the British law common law system, not in China, right, it's opposite the case. In British system is you would, correct me if I'm wrong, you would assume the suspect innocent until proven guilty, right? Which is opposite case in mainland China, where you assume to be guilty until proven to be innocent, right? If I'm not a law expert, so maybe I'm wrong, or completely wrong, but this is what I know for the British system, right? And what do is the judge will start at null hypothesis, the guy is innocent, right? What we're going to do is the prosecutor present a case, right? Which is the guy is guilty, right? And how we're going to do is the evidence or the data, if it's strong enough to reject, right? And strong enough in our case is 95%. Okay. And you will keep the null if it's a reasonable doubt. Okay. And burden of proof is rejecting the null. Okay. So that means that null alternatives are not equal. Okay. Null is only rejected if data is big enough. Okay. So that is a very important idea. And also we know why the case is because we have in the court system, we believe that, right, it's okay it's not okay to jail the innocent people. It's better than you let the bad guy go. Okay, jailing the good guy is worse than let the criminal free. Okay, that is the concept here. It's the same idea here. Okay, so the idea of null and alternative usually for our application would be null is no effect when we talk about A/B tests, right? The new system has no improvement, right? Or we know this equal to certain value, right? Say for example, right, this water is good because it is actually natural, right? There's no contaminant, right? You want to say it's null, right? When you reject, you know the water is from somewhere else, from some unknown source, right? From some crazy places, right? So then it would be that, right? Those who are from civil servant would know what I'm saying. I'm not, right? I'm not civil servant, so unfortunately, I don't get any good pension, so MPF, so for me only. So alternative hypothesis is a second guess, so you reject if that difference, okay? So what hypothesizing is, we need to have a rule to say when we reject a null, okay? Because even this is true, data may tell, unluckily give you this one, right? Same idea. If this is true, we may still fail to reject, okay? Then it's come a rule, okay? So look, this example, I think this is the easiest thing to think, okay? You have a coin, okay? You want to say, to test whether it's fair or not fair. So how we do? Post many times, okay? If it is exactly half head, half tail, then okay, nice. Now it's correct. You don't have to do anything, right? But if not exactly 50, okay, then what to do? Okay, if out of 100 you have 49, what do you say? 51, what do you say? Right? Or make it easier, make it simple, only do 10 flips. Okay, there are many rules you can do, but one sensible one may be 4 or 5 or 6. You think it's 50%. If otherwise, you reject. Okay, of course you can do more. You can like 3, 5, 3, 4, 5, 6, 7, right? And then you keep it. Otherwise, you reject, right? So there's a rule there. Okay, you have to decide before you do the experiment to decide what kind of rule you're doing. Okay, and but do note that no matter what you do, you're bound to have error, right? Even if it's fair con, right? You're unlucky, you can get 6 or 2 or 7 or even 10 head, right? You don't believe that, go to Macau, right? You go to the casino or the thing, right? You can see, right? it can be any crazy thing can happen, right? So it can be, right, a lot of crazy thing, right? So same here. Even this is true or not true, okay, anything would happen, right? This must bound to some error. So that's why we would have what we call the type 1 and type 2 error is whether you do it right, right? So if this is true, you don't reject it, do the right thing, true negative. If this is wrong, you reject it, then it's true positive, right? So that the trouble negative is the idea of you have disease, you don't have disease, and then you test your whether you have positive and negative, right? So that is the terminology in the medical science, right? And if you have true but you reject it, that's type 1 error. This is called alpha, later you see. And this is false, then you don't reject it, it's type 2 error. Okay. And this is what you learned in undergrad already, or okay. So the idea is the same, right? Type 1 error is false alarm, right? It's innocent, but you make him guilty. Okay. So this is you can change this because this is our idea. What is beyond reasonable doubt? We can set it, okay, by our own idea. It's your choice, okay. And B is it is actually guilty, right? But you don't think the judge make a mistake, right? It's a criminal, but you just let him go free, okay. But this guy is you're missing some signal, right? But this is something you can't really control, okay? You can't really control. Of course, you can make a very good cost system to improve it, okay? But you can't really do it. And turn out that these two are trade-off. If you reduce this, you increase this. You reduce it, you increase this, okay? So that is some trade-off there. So when you fix this guy, you have to let this lower. So that's why people ask in after class last time is why 95%? That is by standard. We think that we want to make this as a good trade-off. This is I only allow this 5% to happen. Means 1 out of 20 times make a mistake. Okay, and why? No reason. It just first one who proposed this in the 1930s. He did it. Everyone follows. Okay, there's no particular reason. Someone do it, right? Do it, right? Just like things from the ancient period of time, people follow it. 自古以来就是这样子。对 Then this is the case, right? No one asks why, right? It belongs to this, and this is the case. So I can't explain. The only thing is who proposed first is this. So since the ancient time, like this, we follow. So no one deviates from that one. I hope I answer the question. There's no logic. Just it's like this and like this. I don't have anything to say, right? So as I said, it's 1920s. The Fisher, I mean, the famous physician, he proposed this. Okay, and sometimes we say instead of type 1 error, we take significant level. It's 95%, right? So that's what we said. This is the slide. Okay, and the decision rule is the following. Okay, we will first calculate some sample mean. Okay, and compare the sample mean proportion to what we propose. Okay, if remember this sample mean as a random variable, right? It follows some distribution. Okay, and under this null, okay, you will have some location there, right? You tell me the mean is here, right? It will be, I assume the bell curve is around here, right? Then if the data fall within the likely region, 95% region, we say we don't reject it. Otherwise, you reject. Okay, let me repeat because I think it's very important. So we have some idea to test about the population mean, right? So maybe we want to know, for example, we know the average people, how much they want to buy, say, iPhone Air, right? For example. Okay. And in that case, how are you going to do, right? You'll collect some data, right? And see whether how people want to spend on the iPhone Air, right? In that case, right? You want to see a particular number, right? And we know if our idea is right, the mean will be a bell shape at what we propose, right? Maybe people want to spend $10,000 for the iPhone Air, right? Suppose, okay? And then the bell curve will be centered at the $10,000, right? So let me draw it in case, I think it would be easier to think, okay? So suppose this is, sorry, right? This is money, right? And we think that people want to spend $10,000 for the iPhone Air, okay? And that means that this will be the thing you observe, right? Because you think this is true, it should be, the bell curve should be centered at 10,000, okay? And if you get the sample mean, the data is within this region, then you're happy, right? Right? If exactly 10,000, then you're happy. No question asked, right? You get what you want, okay? And suppose we know the standard deviation, right? So basically, just go left and right by 2 SD, right? Okay. And if our data is within this region, then we're happy. Okay. We keep the null. Okay. If it's outside this, we just null. Because if outside, then this likely, I don't believe it, right? It's too far away. It's not possible from what you propose. Okay. That's the idea. Okay. Let me repeat. What we do is we assume the null is right. Okay. It should follow this one. Okay. And if we are actually largely in this region, then we're happy. Okay. We will say it's innocent, right? What you propose is right. I'm not going to object what you're doing. But if it's far left and far right, then we say, okay, no, we don't trust it. That's the idea. Okay. Because why this case? Because depend on the sample you draw, it can be here, can be here, can be here, can be here, right? So that is the reason why we do statistical tests. And there are two methods. One is called critical value, one's called P method. The thing I show you is a critical value method. Okay. See whether it's within the area or not. Okay. And the P value method I will show you. So critical value method is this 95% will give us a cutoff point, as I showed you already. Okay. It's within, then okay. If not, there's not. So the boundaries for critical value. Okay. The other way one is called p-value method, is how weird the data is under null. What does that mean? It means the following. Actually the same thing, but it is easy to calculate in the new days. Okay. How we do that? Suppose your data is somewhere here. Okay. You know that under critical value method, you don't reject it. Okay. But what's the p-value? The p-value will be calculating the following. You calculate the area on the left-hand side and times 2. Okay? And look at this. It's more than 5% or less than 5%. That's it. Why? Because you don't know it's on the left-hand side or right-hand side. So that's why you multiply by 2. Okay? And then you compare to 5% as well. Okay? If you are here, right, you calculate this area times 2, and this area will be less than 5%, right? The same thing. And you may ask, okay, why we have to do two methods? It's not the same thing. One thing is, in old days, computer is not there. So critical value method is something always fixed, don't change. You only need to keep track of the two values. But in nowadays, you got calculator very cheap, so calculate p-value will be very convenient. Okay, then you just need to compare 5% or not 5%. Okay, and those of you who do statistics, basically just you get 2 star, 3 star, or 1 star. The same idea here. We 1 star, right? 5 star, but 3 star, 2 star, 1 star, right? So that is the idea behind. Okay, so let me go to the example, then you will see what's going on. I guess that would be better, right? So we want to compare the mean is actually 3 or not equal to 3, right? Then what we do is to do the test statistics with the sample mean there, okay? And you will see normalized one. And you compare the significance, which is 95%. Yes, 95%. And then you will see either you use the critical value method or the p-value method, which I will elaborate more in the example, so don't worry about that. Look at this example. Okay, this is the toes and con example. Okay, and suppose you toes 10 times, 9 times head. Okay, and your statistics is looking at average number of head. Okay, there's a sample mean there. Okay, and by using the math in the undergrad, okay, actually we also displayed it. The mean is like this, the variance like this. Okay, so and assume this normal, you just compare this normal, right? So you minus the mean over the SD, give you 2.53. Okay, the critical value for normal is 2 plus 2 minus 2, right? Because 2 SD. Okay, then this is 2.53 is more than 2, right? Either you calculate more than 2 or less than negative 2, then you reject, right? Because it's too far away from the mean. Okay. Why? Remember what you're doing. What you're doing is your average number of head, if it's fair, should be 0.5, right? And you have bell curve here. Okay. And what you do is, okay, look at your data, okay, and what you get is 0.9, right? And what's left is what is the how spread out with this guy, okay? Is estimated by 0.9 times 1.9 divided by 10, right? Which is this guy. Okay, will tell us how far is this guy. Okay, and you calculate this. This is more than 2 standard deviation. It's 2.5 standard deviation. Okay, so that means that this is far away enough from the center because 2S more than 2 SD, right? Is 2.5 SD, right? It's far away. Then you say no, it's not fair. Okay, or you can calculate the area of this on the right hand side. Remember this area you calculate times 2 will give you 1%. So again, it's less than 5%, you reject. Okay, so don't worry with this example, it's just to show you the case. Usually what you do is you plug in the data, you just use Python code. I just show it to you because I thought you would still remember something from a few years ago from the college, but apparently I make a wrong assumption. So I just put the slide back here in case that will be helpful. But we can't worry too much about, because what we will do is always t-test for our class, okay? For many scenarios, it's always bell curve, okay? And then the sample mean will actually follow what we call the student t, if you still remember, okay? And that is like normal but a flatter one, okay? So I will talk about this after the break again, and then we will talk about how can we handle this problem, okay? And then we will actually go into the example again. Remember the on and off applies. I'll go again and make sure that you understand, because this is the most important thing in statistics, is to test whether it's useful, whether the model works or not. Because estimate model is very easy, but once estimate, you have to check whether the model works, okay? The model is good is to do the hypothesis testing. So to make sure that you understand that part. Otherwise, when I go to regression, why I'm taking this model, I'm not the other. There's a p-value, the star will matter. Okay, so I want to make sure everyone knows it, right? I can't really skip this so fast. I keep it slow down a little bit here. But I definitely will finish all this set of slides, right? And then we'll go to regression. Okay, let's have a 15 minutes break. In the meantime, I appreciate if you have time, you can fill in this guy, okay? And I try to accommodate, okay? And if you just write 1, I will assume you are indifferent, right? Because I will just try to please feel free to try to make sure you fill that in. If you don't care, you can just say you don't care. You don't have to write. You can type, if you don't care, you can write this or this, so I know you don't care. Okay. You can also do you reply if you want. Because we're a quiz today, so if you don't want to do it, it's okay.嚇？點解啊？呢個親子都免費㗎。係啊，你買呢個就可以講啦。即係話買粟米呢個就有免費。係食多啦，睇皮啦。冇乜高產啦，網盡咗啦已經。因為根據佢嘅講寫，因為新方面講係咪？你買喺嗰度啊嘛，唔係。咁我哋咪 sell， 佢哋 sell 嘅應該出唔到。即係你幾遠乜嚟解先？加兩件事，就 sell 買出嚟係你睇個邊度加兩件嗰個兩件事嘅話，因為你喺度嘛，定喺附近㗎啦。咁你個喺度咪即係冇改到嘅，有個 data 喺嗰度 ，compose 個 S U 嘅流程用。係啦，冇錯。你唔關係啊？我哋講咁多啦，咁大家已經講到呢個即係校講啦，大家自己俾我哋。佢已經話我呢個咁難，我呢個睇本第一睇頭教嘢，但係要有讀過先係咁係咯，我係冇時間講多，唔夠我唔夠都可以講起㗎嘛，唔係驚大家都會鬧死我啦，係咪先？我講就鬧死我，唔講就鬧死我。係啊，就一即係係咯。P.V. 做，如果細過5%咪唔使，但係你嗰時計下幾遠啲，即係計下 U.S.D 有份係 S.2.S.D 嘅。 如果呢個 P value 細過5%，咁咪就係你一個 percent， 2.幾個 distance， 佢兩個 cent， 2.5個 centimeter， 0.9同0.5嘅距離度，2.5個 centimeter， 咪超過2啦嘛，超過2就拜拜，因為95%嘅機會率就係兩個 SD。就計尾巴乘翻2，或者計尾巴係咪大概0.2咪得咯，都得。即係是但一種方法。係是但方法。咁呢個一個歷史上計法，一個係有啲 output 出嚟啊嘛。你唔講俾聽 ？B.A 就係話有幾有可能呢嚿嘢會出現啊？咁奇怪仲出現啊？即係有幾咁冇可能？要 given 你個 no 有幾咁神奇？就係 P value。
即係 P value 我聽有好大機會都會出現
你可以 define 嘅，其實係 probability success 呢個啱好呢個 no 係會 get reject， 你可以咁講，但係我費搞你，我講呢咁嘅嘢，咪大家會實死嘅喎。啊？
正常嘅冇細細。
P value 可以咩數得嘅？可以0.，如果 P value 中間咪1咯。如果你係咁啱係 exactly 個 point， 咁啱係你個 no 嘅話，咪1咯。即係兩邊加埋0.5左右，2邊可以係，好咩都得㗎。There's no limit， 零同一之間都。啊？我普通話就唔好意思。唔好意思，我因為我太太嚟。我哋咁我識講啊。That's my Managerial。當然我睇嗰啲我包證。我唔知你個年代啦，我個年代。我哋個年代唔係普通話㗎，唔知你我個年代點講啊？我係到中學咗3年，就係音標都未講晒。音標都未教晒，音標都識3年，我哋我都未教晒，冇俾學嚟食。嗰時9年代，8年，我係8年代，話相比94、95、96、96，對啱啱97、98即係我。冇嘢可救啊！你講。因為係呢個食下嘢政府 S 即係加兩倍嘅先。落去。有用 SD setting off， 正如 S， 你呢個係 SE 就係 standard deviation of sample mean。SE 係 SE 方法係 S 啦。咁但係因為呢個 SD 喎，你個 sample 就係 estimate 緊 SE 啊嘛。SE 係咩事嚟嘅 ？standard deviation of sample mean。咁呢個係 population test。係啦，呢個係我真係 create 咗好多個 sample mean 出嚟，咁個 SD 咪就係個 standard deviation of sample mean。
但係因為上次我哋問啦，譬如話嗰唔係 population 嘅邊嚟㗎嘛，咁呢個咪應該係 population 嘅 standard deviation。
唔係呢個係你計出嚟嘅 mean of 呢堆 sample mean， 即係話你講緊你呢個係呢一紮嘅 mean。就係呢個，呢一紮嘅 SD， 點知 population 點知 population 你永遠都唔知道噶嘛？
咪就係攞晒嗰2500，
嗰個係你嘅 sample， 呢個係你嘅 data 嚟噶嘛？你 data 再 resample 啊嘛。嗰個唔係嗰個2500都唔係真嘢嚟噶嘛？
咪就係嗰10年，
但10年都係你嘅 sample 嚟噶嘛？你都唔知道實際上，你實際上個 universe 係咩啫嘛？
你嗰10年
係個 data， 但係你個 data 唔係真係個 population 嚟噶嘛？你嗰個10年都係個data 嚟㗎，所以呢個因為你可能出現唔同嘅 data 㗎嘛 ，potential 嚟講，你即係見到一個 universe 啊嘛 ，potential 1萬個好多個 universe，
哦，因為呢個就係 sample mean 同 sample SD。
呢個係mean of 呢堆 sample mean，呢堆嘅sample mean，呢個係呢堆 sample mean 嘅 SD。咁就係呢個，你呢個其實都係想 estimate 緊我呢個嘢啫嘛，就係 standard of 呢嚿嘢。呢嚿嘢可以透過呢個 estimate 估出嚟。
都係 population SD。
呢個係。
咁但係我哋以前讀書即係可能有得係咁樣計㗎嘛。
呢個你係用 sample variance 去估個 sample mean，唔係個 sample variance 變個 population variance。咁 population variance 如果你 by root n 就係 percent deviation 嚟嘅 sample mean。sample
variance 其實真係好似我哋而家呢個咁樣。
咩意思？
我哋以前係要長翻開放 n 咧，咁係好似
唔係 sample variance 一定係呢嚿嘢 sample S 呢個 sample SD 嘛。呢個係 sample 呢個係 sample mean 嘅 variance， 唔係 sample mean 嘅 variance， 唔係 data variance。
呢個就係 population 嗰個
呢個 population 嘅 SD， 呢個係 sample mean 嘅 SD， 唔係 population。
實際上我哋點樣揾個 population 嘅 SD？
sample 定 sample SD？
個 sample SD 攞嚟
係啊，
咁又係要除翻開放 n 啦。
但係呢個除咗 n 呢個係 sam 呢個係 standard deviation of the sample mean， 唔係 origin 嗰個。你打嗱，一個係你本來好多全港人嘅 standard deviation 一嚟啦。但係呢個你係話你揾佢嘅單同佢嚟計咗 sample mean， 幾多個 sample mean， 咁啲 sample mean 嘅 variance 先係。
咁我哋10年嚟股票都唔係成個 population，
唔係㗎，所以你都估計出嚟㗎。你見到 data 都唔係 population 㗎嘛
？resembling 同 bootstrapping 我就明白，即係抽 sample， 但係即係 historic 嗰10年可以買。
唔係你嘅 data， 你睇到嘅都係 data。population 係 potential 年係可以裝出嚟嘅事。
不過呢堆股票都揾唔到 population，
冇㗎，永遠揾唔到㗎，永遠揾唔到㗎。你股票都係出嚟都係你嘅 sample 嚟嘅啫嘛。
話 historical past 就
唔係㗎，唔係 population。population 係你所見到嘅都係 data。
我以為界定嗰10年嗰個就
唔係。你可以咁界定啊，不過我哋唔係咁諗啦。對啊。有3分鐘，小兩講先。
So I hope you have filled in. I don't know how many one will fill in because that would determine how I fit your thing. So if you haven't done it, please do it. So the idea would be the following. Okay. I'll look at how many groups you're doing. Then I will do a random draw of order. And that would be, then I'll just try to fulfill your order as much as possible. Okay. And we have last two classes to do your presentation, but 1 hour will be due for the exam. Okay. So 1 hour exam, the last class is with 1 hour exam. Okay. So that means that each class we have 2 hour 45 times 3, right? It's like 2 hour 30 minutes, right? So at the end, we only have 4 hours at most. Okay. But include the break, we have 3.5 hours. Okay. So it's like less than 200 minutes in total. And we have 70 students around, 77 something. So it's if we allow 3 minutes for each one, we slightly overrun. Okay. Then we cut the break shorter, then make sure everyone go home on time. So basically you will be expecting 3 minutes per person. Okay, per group. Not every member in the group has to talk, but at least one people talk. Okay. So are you done? So we'll do lottery. Okay. So we have 13 group. So let's see how you can go and do. So what are we going to do? Of course, we have Python class, right? So let's do Python. Python draw. So let's see how we're doing to do the draw. So we'll do it by using the idea that this. Okay. So I will use the NP random choice. Okay. And I draw it, right? And then same the size observation and just I will draw without replacement, right? So that's what we do. Okay. So that would be something like this. I maybe copy this guy is easier, right? Let's do that. Okay. And let's see how many we have we have 14 group. Is it the complete space now? I think it's almost. We have 72. So we have 14 group. So let's do it. Let me open a new file. So we have a list. We have A for X, right? Is and Okay, so what I'm doing is like this. Let me run that. So we have 13 group, right? Is it right? A 14 group. So this is 14 group there, right? So we're going to draw number there. Okay. So let's call X of this guy. Okay. That's what we're doing, right? This is the guy. Okay. And then this is just example. We are not going to take it seriously. Okay. So, and the size is the, so U is the length of X, right? There 14. Okay. So I will draw 14 observation there. That depends on the length of X. Okay. And then replacement, we will say to false because we don't replace it. Okay. This is example. I draw, the answer will be the order. Okay. I just show you the example first, not the real serious one. It's example only. So we have 0, y, oh, I forgot. Did X, sorry. There's this. And the example we draw will be like this. That's example. Okay. Now we are going to draw. Okay. So let's make sure everyone's here, okay? Only 14 group. Okay? Only 14 group. So let me draw now. 1, 2, 3. And then so 40 number 1. So we will make him happy. One and then 193, right? 1 9 3. Okay. And then 13 10 11. 13 10 11. And then 6 8 4. 6 8 and then 4 and then 12 2 and then 12 and then 2 4 5 and 7 and then 5 and 7. Okay, so this is the order. Now I'm going to allocate according to the number of people, right? So now according to the rule, priority 1 would get the thing. Okay, so we will make her happy. So happy, done. So we are done with 6 minutes. 6 minutes is over. Okay, so and then we will be number 2. Okay, so let's go to calculation. 13 and 20. Okay, we have 2% here, and then next is 6 minutes over, right? 6 minutes, 2 people. And then 20 is we satisfy, or number 2 will be this one. Okay. Satisfy. I think we have 6 minutes. And then 21 minutes is over. And then number 3 will be number 2. Okay. 20th. That will be how many people there? 1, 2, 3, 4, 5, 6, 7. Okay. And 21 minutes over. Okay. Okay. And then number 4, priority 4, with 20th again. And that will be 1, 2, 3, 4, 5, 6, 5. 50 minutes. And then number 5 is 20th. Okay. It's going to be 6 minutes. Okay, this is fine. And then number 3, number 1, 2, 3, 4, 5. Number 6 is again we have 4 people, 12 minutes. Okay. And then number 7 is again 20th. Am I doing group? Assignment is individual. Okay. And then we're going to number 7, right? It's 1, 2, 3. We're done, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. 7 is 1, 2, 12 again. Okay. Yep. Right. 6. Yeah, we're done. And then number 8. Number 8 is this one. We can fulfill. 1, 8. We have 21. Okay. And then number 9. Number 9 is here. How many minutes we have? Okay, should be fine. Number 9 is we have again 7. So should be happy as well. And then number 9 is over. Number 10. Let's see number 10 can do it or not. We already have 1.5 hour. And if I do it, maybe okay, but if you guys can keep the time on time, otherwise have to go home a little bit late. Can you do it on time or not? So let's say let's make this the last. Okay, maybe it's okay, I guess. Let's fulfill that. How many? Right? No, is it? No, sorry. Sorry, where did I stop? I forgot. We have, sorry. 1 is done. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. It's about number 10, right? Number 10, we have 5. Could be fine. And then number 11 is okay. And number 12, I'm sorry, we can't. And then so basically is we're almost making everyone happy except one group. Huh? Oh, 15 can also will be also doing the 13 as well. Yeah, just it's okay. We will assign him 13. Okay, so that would be the our presentation slot. That should be fine. Okay, so that would be our presentation. Should be fine. If I check if I make a mistake, I know, but this is the according to the rule. Okay, I mean if I make a mistake, let me know. I'll double check, but that should be according to the rule. Okay, I try to satisfy as much as possible, and this is a well-known procedure called random serial dictatorship. If you know microeconomics, then you know what it is. Okay, but you don't, that's okay. Any question? Okay. Oh my God. Oh. Mm. So I guess to keep everything on time, so I recommend we do 2.5 minutes for each one because make sure everyone go home on time. So I don't want everyone go home not in time. So everyone prepare 2.5 minutes, maybe 2 minutes, maybe better. Maybe to make 2 minutes. Every people make 2-minute presentation. So we make sure we are on time. Okay. So make sure that at least one person from your group present. Okay. If no one present, then your group will get 0. Okay. At least one of your group will present. And if you don't say anything, you will get the average score. Okay, assume to be. And if someone do exceptional, you get just higher mark. So I don't deduct if you don't do well, but if you do better than your group, I give you extra credit. So everyone will assume the average score. If you do particularly good, then I increase the score of you present. Okay. If just one guy do very well, then of course everyone's saying. If you do not so good compared to others, you still get the average. So there's no harm of saying. Okay. So I hope that is okay. So everyone get 2 minutes, okay? Everyone 2 minutes. So for Lucas, maybe for him, he can have 3 minutes because he's himself. So give him 1 more minute. Otherwise, 2 minutes, okay? Yes. You have 1 hour exam. and then this, yeah, and this. So we make 2 minutes, so don't overtime, otherwise you guys go home late, okay? I don't want you guys go home late. Yeah, individual, you have extra time a little bit. Maybe give you 3 minutes, it's okay. Okay? Is that okay? Any question? If no, then we will continue. Well, to be honest, I don't like presentation, but for B school we do presentation because sitting there is very boring. You can see, you can feel it, right? Talking is not boring, but you're sitting there, listen, is very mind-blowing. So I prefer not to presentation, but we have the presentation. So I'm sorry to bother you with your talk, but we have to do it. So this is the standard thing is we assume there's a bell curve and we do the t-test, test the mean. And some of you ask me, wait a minute, right? Bell curve doesn't satisfy every case. We learn the bootstrapping and resampling. And indeed, you can also do the bootstrapping idea behind hypothesis testing. You can also have not the bell, instead of bell, you can bootstrap. You can do the same, give you the not 2 SE, but will be 2.5% percentile, give you the range you don't reject, otherwise you reject, same thing. But our class, I don't want to bother you with that, but it's feasible to do that as well. Okay, but anyway, so that is the outcome. Again, this what oftentimes we do this is we want to see the mean is equal to some number or not equal to some number. Usually this A is 0 because we want to test the model. We want the parameter to be useful. The parameter is useless is 0 usually, right? Or either 1 or 0, depends on the type of model. And if this is 0, the model is useless, right? Like the regression, which we'll cover today. Usually we want to see whether it's 0 or not, right? The parameter is meaningful. So usually check is you take this minus what you propose and over the standard deviation of this guy, and turn out to be, if the sample mean is t distribution, this is what you learn in the undergrad, if you still remember a little bit, but if you're not, it's okay, because everything we've done by program anyway. I just give the background because we don't actually want to ask you this specifically. Rather, we ask you to read the table and this is behind, right? It's because of, you say this is A, right? It must be bell curve around A. You try to see is there any 2 standard deviation from that as well. Same idea, okay? And some of you ask how this is different from the bell curve, okay? And indeed, when n is more than 200, the t will be the same as bell in general, okay? So that means that in your data, I don't think you work less than 200, right? So you can just simply say the bell. It's the same as 2SE, okay? And as we said, plus minus 2, so basically like this idea, right? It should be around 0, right? And then within this region, you don't reject the null, otherwise you reject. Okay? Let's do something. No, nothing. So let me give you the example, right? This is your data, okay? And you want to see whether this data is different from your number proposed, maybe 0 or 1 or 2. The idea is you use the numpy and psi py from stat in stat, and the t-test is just very simple. Stat, t-test, one sample, give me the data, you take a difference. Tell me your value, right? Is it very different from 0 or what, okay? And turn out that this p-value is 1, okay? And that means that you can't say it's not 0, okay? Because the sample size is so small, so you can't, it's different from 7, it's not. We can't reject it, right? Because 7 is exactly in the middle, right? So that's why p-value is 0, exactly 1, right? Because you're exactly right, you can't really reject it, right? The mean is actually 7, and you say the null is 7, of course you can't reject it, right? Because you actually get the null. Okay? And you can change this data and figure out what's going on, okay? And actually this is, you want to check, right? this p-value you can't reject, or the t is not bigger than or smaller than 2. It's bigger than 2 or smaller than -2, right? It's not the case, so you can't. And remember, this is the idea talk about the billions prize project, right? It's a lot of prizes online and offline, and we want to see the same product, the online price and offline price, are they the same or different, right? You want to see whether this new variable is 0 or not. Okay. And I think we talked about this in the data, right? And why encoding, because of the data has a different type of character, not just English, because it's around the world data. So that's why you have to do some encoding and focus on USA data, regular price, and there should be not an online sales, and you should have both price and online price, and you focus on the price that is less than 1,000. It's not expensive good. Yeah. And then you can calculate the EDA, right? Look at the mean, SD, and this negative, the mean negative is the difference, right? This case is online price is online price is less than the offline, so negative, right? If online price is more expensive, it's positive, right? So anything can happen. Okay. And you can look at the histogram, right? This is the data description. You can do the describe, or you can plot the graph, this one, and someone point out that I have a wrong x-axis last time, so here I correct it. So this only change in the graph there. And you can do the the analysis, right? Looking at the standard deviation, right? And try to see the SC, and then you calculate minus and over the SC is 0.4, which means that it's only 0.4 SD from 0. It's not 2, so you can't reject, right? Because it's within 2 SD. Okay, so you can't say they're different, so they're same. Okay, and of course you can actually calculate that instead of using the t-test, right? Either you can do the calculation, calculate SD, calculate N, and SE is based on this one, okay? And of course, if you don't like this, you can do the bootstrapping or resampling to calculate this SE. Okay, the same procedure we have done. So this, but we do it this way, okay? And you do the t-stat and compare it to the idea, okay? And then, or you can do one step and done, right? Do a data and see it from 0 or not. So this is what you expect to do, right? You don't really need to do all the calculation, right? Just tell me, okay, I want to see whether it's 0 or not. Just use this formula and you're done, right? Of course, I can just teach this one, but otherwise, but you don't know what's going on behind, right? The behind is look at data, right? Look at price difference, is 0 or not, right? If under the null, it should be 0. So in the data, it shouldn't be different from 0 too much, right? If different from 0 too much, then you reject the null. And you look at how different from 0, turn out to be only 0.4 SD, right? The idea. Okay, let me draw a picture, right? Basically just like this, right? If it's 0, it should be normal, right? Normal like this, right? And it is, and then to figure out that it's only, this is 0.43, right? Basically just asking the data is only 0.4 SD from the mean. It's not 2. Only 2 is big enough to say no. Okay? It's either 2 away from it, it's small enough. Okay? The p-value is 60%, right? Means that it's not 5%. So it's not small enough, you can't reject it. Okay? Either this one or this one, same thing, but you don't, the same idea. Okay? So don't worry. You only remember in your head is always p-value. Is it less than 5%? That's the usual thing. We'll be doing this, okay? We are not going back to ask you to derive all these things, but we rely on the p-value. P-value is the goal because after the model in regression, we want to see the p-value is less than 5% or not. That's the thing we will carry immediately in the regression. Okay, so that is the main point. Of course, I can skip this class and get the p-value thing, but that's not serving your purpose. Okay, the idea is whether assume it's 0, right? It should be around 0. If 2 different from 0, then the model will be useful, right? Because by chance it can be non-zero, right? But how much from 0 has to be 2 SD from that. Assume the bell curve, right? Because 2 SD from that will be the bell curve we say, right? It's 95% should be within the 2SD. If beyond 0 by 2SD, then your model seems to be something useful. So that's the idea. Okay, I hope you get it. Usually we don't do it directly. Sometimes we do, but the most useful thing is going to test your model is good or not. But of course, you can see this testing the price online, offline different. It's very useful. This usually we call A/B test, right? This is actually the A/B test. The same thing we do online, offline, to a difference, right? You can imagine this is the same idea, right? Because the same idea applied to A/B test, right? Because you can imagine what we are doing is look at difference for the same good offer online price, right? You can do, you have a system, okay? Under the new system and old system, how fast is the website response time? Or under the new product, how people like your product or not, right? So this is the idea you've been, that's underlying all the A/B tests, right? Look at the difference and see difference is different from C or not. Okay. So I hope I kind of go over that. I mean, of course, if you still feel it's a little bit difficult, I understand. It's not something that you can absorb immediately because of this is, if you go to undergrad class, actually I cover 4 to 5 weeks for this material. Okay, half of them. And that's what I do during the day, right? So I teach statistics during the day. So I cover this thing at least for 4 or 5 weeks. Actually, at least at least much. So I cram it in one class, so must be very difficult. Okay, I do understand. But I can't really go into very detail because some of you know would find it very boring. So that's the question. Is that okay? I mean, I do understand there's an issue, but don't worry. If you do the assignment, you will do it. Then I will give you look at it again. Then you will know. Okay. Then you can ask me again by that time. Just like your assignment, when you do it, you know the bootstrapping and resampling. When you do the assignment, you know whether you don't know. Okay. Only by doing the assignment project, you know where you don't know. Okay. You never know whether you don't know, right? Only if you are tested by exercise or assignment or quiz, then you know which the part is falling. Yes. P-value must be 0 to 1. If, say, the example we have shown, what's a p-value? If, say, this is exactly p-value is 1. Why? Your data is like this, right? Your data should be 7 is here, right? Normal is like this, right? And your data told me that your assume is this one. Your sample mean is also 7, right? So where is your data? Your data is exactly the null there. Okay. And p-value is going left or right. Okay. Doesn't really matter. You go to the left-hand side, but rest the same. And you times 2, right? Left-hand side is symmetric, right? 0.5 times 2, 1. Okay. Of course, if you don't say 7, say suppose you say you think this is only 6.5, say for example, what the p-value? Suppose you say this is instead of 7, you say 6.5. Okay, say 6.5. Okay. What's the p-value in this case? Will be this, right? Because you say your data is say 7, right? The sample means 7. So your data is here, 7. The p-value will be this area times 2. That's it. Okay, of course, don't worry. You put in the Python, give you the answer directly. You just need to do is look at the p-value, 5% or not, and you're done. Okay, you don't need to worry about how it comes, right? If you want to care, I told you already how to calculate. Okay, is that clear? Very good question. I mean, please do ask because by asking, you know, right? Otherwise, I mean, I don't want to keep you in permanent darkness, right? Because you come to here, you want to learn, right? You just don't want to. I tell you this, you believe, right? Right? Maybe you want to do it, but that's better if you understand, right? Because you can always ask AI, right? Why you come to the class? Must be some reason is I can answer quickly. But AI can also answer very quickly, right? But I can give you the idea that what is needed and what's doing the exam, right? AI will not tell you what is examinable, right? I can tell you up to the point that you need to know, right? AI doesn't know what I'm going to ask, right? And my value is I made the exam, right? So I will tell you that what is included, right? What should be you need to know, because ask AI, they will give you a lot of things that you don't need to know, right? Is that okay? But I mean, yes. Any question? Because we go to regression. We're done, right? We're done with basics, right? All the tools we have learned is already there. So we'll be going to the real stuff. Because so far, it's just, if you learn statistics, there's nothing new, right? If you really learn, say, for example, you go to the high school, you learn M1, just this one. There's nothing more than M1 in the high school. You know, now with the exam, there's M1, M2, the basic math. And M1 is the little bit more advanced, and M2 is less advanced. And M1 is, in the old days, is the people study art, not a science stream. It's going to be M1. So this is something M1. Okay, it's not something complicated at all. Okay, anyway, if you don't know, ask your cousin who do high school, then you know how to do it. Nothing new there, except the bootstrapping and the resampling. They don't study. Okay, and most of the thing we cover is high school. Unfortunately, high school level. Okay, but our idea is more far advanced than we cover. I just say the math. Okay, not the idea. Okay, so don't think I'm teaching high school to you. Otherwise I add no value to your education. Okay. Any further question? And if no, then we go to lesson 4. That's the real deal now. Okay. I do remember that we have a quiz at 9. So let me start real quickly, and then we'll break. And then we have 15 minutes, and then we have a quiz. Okay. So regression and messy data. So regression, I understand that you learned it from your machine learning class. Okay, I assume you're expert. No, okay, I will assume 0 again. Okay, 0 again. Okay. Well, if it's too easy, let me know. I can speed up. Okay. So we're going to do is we go into the thing that we will using data to estimate model. So now we have a model. So far we don't have a model. Now we have a real model. We will estimate something real and how to use them. Okay. So let's get started. Don't waste time. So the data is here. Okay. So what we want to do is something very simple. Okay. And since you have learned it in the machine learning class, let me not do it in linear order. I just do it what I think is fastest. Okay. Suppose I have data X and Y. Okay. X may be the time you spend in the school. Y is your income, right? You want to see how much you earn more depend on how many years you're in school. Okay. Maybe the data is like this, right? This individual 1, 2, 3, 4, 5, right? So a bunch of data here, right? Something like this, the data. In general, the data look like this. Okay. And look at data means that the more school you go to, the more income you have, and that's why you're here, right? The master degree has some return, okay? And in general, it's like this, okay? And in the data, it's actually like this. What happened in the orange? It is Ph.D. So if you go one more step, I'm sorry, you are going to earn less like me, okay? If you want to earn more, don't continue. That's the end, okay? That's the real data. I'm not joking. This is actually the data, okay? Not fun, but not fun for me, but fun for you guys, right? So, but anyway, you can see that the general trend are going up, okay? And you want to quantify it, okay? And how to quantify it? There are many ways you can quantify it. The simplest thing you can do is kindergarten thing, draw a line, right? The easiest thing to relate to thing is draw a line. Of course, you can draw a curve, but line is easiest, okay? And regression is the way how to systematically draw a line. That's it. That's regression. That's regression, nothing more, nothing less. And how to draw a line? Of course, there's a lot of method, okay? And what is the optimal line? Is the line that in our application, the basic one is called least square, is minimize the vertical distance. You learned that, I think we learned that already, right? It's just like the line. The best fit will be the one that look at the vertical distance. Okay. And each distance, you square it like the variance. You square each distance, sum of distance, okay? Which line is minimize it will be the line, okay? There are many reasons why you want to do it. We'll talk about this after break, but this overreaching idea of regression. And of course, this is only X and Y. Of course, you want Z more dimension, right? Then the underlying is like this. And if you learn a lot of complex model, it's still like this. But you may be fitting a non-linear line, okay? And if you learn random forest or regression tree, it's still the same. It's just like you cut this into multiple sections and do regression within, right? There are many things to do, but we are not machine learning class, so I'm happy to skip those. But you will be learning from the other one. But I still keep the regression because regression is the thing we need to do causality. Okay, so we still keep that. But we will go very quickly. We will leave the important part to the other class, okay? Because you don't want overlap, right? So I give you the main idea and how to do the Python. You apply it. All the details will be in the machine learning class. But you will have just enough knowledge to do your assignment, to do everything rest, okay? Because I don't want to overlap too much with the other class. But I will just keep the minimal. I will just also talk a little bit of LISO as well, but only minimal, and then the rest will be in the other class. Okay, because I don't want overlap. Okay, so let's have a break of 15 minutes, and after that, we have 10 minutes, and then we have a quiz. Okay, so let's have a break of 15 minutes. I see you. 冇問題。有個問題係，如果你做同一嚿，唔可以同一個 project，唔可以同一個 project，一個 project 兩個科實。
另一個命題啦，
你可以做唔同嘅 report，但係唔可以用，唔可以同一個 report，係咯。
嗰啲 data set 可唔可以用 synthetic data set？可能 target 上有啲係
可以冇問題，你話你 class 一定得啦，冇問題。唔會，但係你唔好 synthetic 個 data 我1、1、2咁就好 synthetic 就唔得啦，係嘛？你 synthetic 得嚟係有啲嘢講到嘢，如果唔係你啲頭話咧全部都係零，跟住我換咗全部都係零，咁我唔可以冇嘢去講啦。即係你 synthetic 嚟到係有啲嘢啦，係咪？你如果你係咯，即係你唔好話全部都係零，全部 data 都係零，跟住就話我做完啦，冇 calculation 咁我唔可以俾分你。你明我嘅意思啊？係咯。
睇嗰個 analysis，
睇你點樣做啦，係咯。
但係你中間唔使 solve 咩 problem，
我唔
係
得每個人得2分鐘嘅分。
即係純描述啲 describe。
你一定會有啲嘢做㗎，係咪？
有嘅，但係我哋研究就發現辦法。
都係答案咯，咪答案咯，係咯。你咪冇做，即係有做嘢，發現冇嘢，咪都係做完㗎啦。
solve 緊嗰個係。
咁你有個問，你開始有個問題㗎嘛？你係
我哋有埋即係。
唔好意思。
所以就你記得即係
你講咗先。
有冇需要做類似 prediction 咁嘅？
嗰度 prediction 但係 prediction 都夠啦。prediction
唔係啲數啦。
即係話你呢個 point 上嚟冇嘢㗎嘛？咁你如果呢個已經 prediction 啦。如果上邊都
即係攞嚟啲 data 解釋好啲嘢，即係話啲 data 見你現象出嚟，佢咧係做乜嘢？
其實我哋個心已經睇到啦。
明白。佢大家做翻咁上下嘅嘢，就咁上下分咯，係咪？係咪？即係唔好太多，但係即係唔好俾啲太過影出嚟都好難睇嘅嘛。
因為教下 data 嚟咯，覺得嗰度好似好棘頭咧，驚啲 data 平嘅。
我哋呢啲
夠即係。
嗱，依樣俾你 work with 嚟幫 work with 啲問題。冇問題就按照你嘅都幾多咯。而家唔緊張。
講咩？有冇 tips 啊？tips 有個 tips 係今次
記得翻學。
今次你 present 嚇？
細嘅花生。其實睇嗰個即係好多嘢想記到。我咪有細個咪有個嘢問，嗰個就係內都本過一個，嗰個即係內嚟，嗰啲你計，佢真係好似係完全 random 啲評分咁樣，因為你 check 翻咧，其實本身你見到scanner、male、female、transgender 實翻係全係一樣咁多人，跟住點解 female 都可以 gay，點解 male 都可以 lesbian？ 呢個根本冇可能發生㗎嘛，所以呢個 data set 真係可能你第一個咧即係第二個嗰個咧被 reconcept 嗰啲咧一個都係 table 嘅 data。我都係將你哋可以放下我條正我哋咧，你可以問翻我㗎，係有成200個，你可以200個佢一嘛，咁中間問我咁咪高多入邊就係第一個條咩咯？你可以用 content 嗰個 scale 係如果即係多即係費就睇唔夠咯，因為呢度佢清場啊嘛。哇！佢睇醫生，可能睇醫生。即係你點睇你？我哋嘅咩講法？係點？因為我傾咧，有啲老師佢幫我講啲嘢嚟，嗰陣而家又嚟嘅，嗰個係咪個？兩單手，就係咁做，問題嗎？咩時候？哦，唔係喺度嚟嘅。
呢個如果我平時睇開嗰啲係成1.96%嘅 error，但係點解今次係直接用佢字嚟？
我一定嗰度有寫嘅，但係1.6當2啦嘛，有分別㗎嘛。
即係如果我係當98%嘅話，就
1.96得，但係本書就咁樣教㗎嘛，佢當2咁做，佢嗰度有寫㗎，1.96當2啊嘛。
Yes.點解會有點解你問呢個問題咧？好第二問題搞嚟。你點解抽表？應該10月中旬睇到嘅。我唔講呢個睇呢個，要睇呢個。咁我呢樣嘢唔得啊！我會俾人捉住嚟砌㗎。我哋教呢啲唔係，即係我哋都要拎去。我哋 ACS 呢樣需要，唔係我都教得。係啊，要而家唔係我有好多邊啊，我有啲邊啊，好多。我 I D 嘅，你自己知道啦。呢個啦。
So 7 of you say no to extension to the assignment, and we are going to follow the supermajority rule because this is changed in constitution, right? We need a very hard deadline, hard. So 50, okay. So we have an extension of the thing. So let me officially do it now. So we will extend it to 16. 16, I make it end of day. So it will be end of the 16. Okay. So you can enjoy your holiday more. Okay. So that's okay. So we have some minute left. Okay. But we still want to talk about things. Okay. So remember, regression before the break is the following. Right. It is, I want to have a line that fit the point the best. Okay. Of course, if 3-dimensional is a plane, right? If more than 3-dimensional is super hyperplane, if you know what it means, but basically just like still try to minimize the distance between the point and the plane or the line. And this line, of course, it's a line, but what does that mean? Okay. And is it different from correlation? Right? Is it different from covariance we learned, right? The problem is it going to mean anything? Okay. And regression, usually you will see 2 uses. One is you learn in other class, it's called prediction. Okay. Which is saying that if I give you this X, on average what y should be. That is all prediction. We are not saying that if you change x, this lead to this y changes. It means that if you observe that x, that is the y. It didn't say if you move, you take more education, actually we reduce. Doesn't say anything. Just happen to be, if you look at the people that have the year of education, that's what their earning is. It has no saying about additional 1 more year, this is what you earn. Okay. If your data is based on observation. Okay. Of course, when this regression will have causality, means you change 1 more year, this is how much you earn. When you have this, what we call causal, one way to do it is you become a crazy scientist. Randomly assign people. Some of them go to 1 more year, some of them less year, some of them so on and so forth. Okay. In that case, that will be causal. Okay. Because it's not the human choice to decide whether they take 1 more year. Right? The reason you want to take this class is not the result of tossing a coin. Right? You're not going to the temple and ask the god or there, should I do the thing? And then you toss a coin and decide whether you want to do it, right? You must have some benefit and cost analysis, figure out that you come to here is better than go to the bar, right? At least for this 1.5 year, right? 2 years, right? Must be decide benefit, better and cost. So it means that if I look at data by itself, it's not going to be any causal, okay? Because it involves something I didn't observe, and it may be something important, right? But if I just randomly assign people to take master, right? Suppose we just do a lottery. Okay, these people have to take the, right? And in that case, that would be causal. And you ask in this world where there's something like this. Yes, you do. Indeed, there's a lot in the old days that because at least in the US, in many places in the world, you have compulsory education, right? And then you can only quit school when you become 16, right? Many places or 18, depends on the regime. But 16 depends on when you're born, right? If you're born in December, 16 is very quickly. If you're born in January, right, you have almost 1 more year school, right? By exploring this kind of thing, you can know people randomly assigned, right? Assume that people randomly born during the year. In that case, people have random education, 1 more year, less year for those who drop out. So look at those who will drop out, and then you look at who born in the January, who born in December, and can see the difference. Okay, there's something you can do, but that's beyond the scope of our class. But we'll, at least for these few classes, we'll talk about this later. But at least, as I show you, there are 2 ways to interpret. One is causal, one is predict. This is what you learn in the other class. Okay, our class will talk about causal. Okay, this is what we learn. Okay, so that's the difference. And all the machine learning, currently most of them are just prediction, right? Because you learn LLM, right? Large language model. It's just based on what the text before, of course also after, and predict what the word should be, right? And that is prediction because they are not trying to understand the word, right? Of course, these recent years they are talking about causal machine learning, try to let the machine really understand something. But anyway, that is beyond the scope of our class. Okay, but we still but this one still rely human. Okay, so we still not replaced by AI that soon. Because you will see in the later in this class, causal analysis require more than statistics. You require some domain knowledge. You need to have some idea. You have to write a theory, or draw a theory by means you have some model, some idea how things are related, and then the regression will be meaningful. Okay, then that will require domain knowledge. So that will, I will teach you the technique, but it will require domain knowledge as input. So here we have y and x. X is something you want to use to predict y, or you want to say x cos y. So that's the thing. Okay. And there are many types of regression. The first one is called non-parametric. We will learn two forms. One is called bin scatter plot. The other is on Lewis. And later you will see it's not complicated, but just telling you how to do. And probably you never learned this in your undergrad, but I think you will learn this in other class and undergrad as well. The easiest one is the line, fit the line. A plus bx, right? B is the slope, A is the y-intercept, right? And you also learn this kind of non-linear, you plot exponential or quadratic or any form, okay? So we will do this in the upcoming 2 to 3 classes, okay? We do the regression, then we will do some causal analysis, okay? The upcoming 3 to 4 classes, we will deal with all this kind of regression, okay? And you don't learn all this. I think you learn something in the other class, but if you figure out that I have too much overlapping other class, let me know. I just jump much faster. Or you will benefit from another view of the thing, it's okay. Okay. So you tell me whether overlap. So don't complain at the end. Okay. Because they always complain at the end that things are so similar. Okay. But if it's similar, let me know. I just cut, right? We have more material than we can cover. So don't worry. I will not do stand-up comics, right? So anyway, let's do. Okay. The first one is easiest. It's called the bin scatter plot. Nothing new, but it's very similar to what we have done. It's plotting this scatter and by group. Okay. And that turned out to be very useful. Okay, let's see. Bins we have done is divide X into multiple group and do the Y. So that's a model. Let me draw a picture because that would be the easiest thing to think. Is the picture because all of us are very tired in the math, so it's easiest. Okay, look at this picture. Okay, so the easiest model you can imagine, okay, is like this. Okay, suppose this is the primary school, okay, and this is high school, right, or secondary school, if you use terminology here. This is college, okay, your bachelor degree, and as I said, this is the what? Your master degree. That is, you'll be here, right? For some of you doing second master degree, I don't know, but if you're only first, this is you jump here from here, okay? And people like me is here, is a doctoral degree, okay? So you have naturally have 4 different group, okay? I mean, of course, in the data, probably you don't have this natural distinction, but imagine you cut this into multiple groups. And what you're going to do is in this group, you disregard the X. What is the model? You tell primary school, you do the average of this. Forget X, look at the Y. Where is the middle? So you pick up primary school. The model is this number, and this number is the mean. Mean means what? You look at the distance, right? All the same is in the middle. So this is your model. Replace anything by this. Okay? Means that you tell me if you have no schooling, 1 year, 2 year, 3 year, 4 year, 5, 6, up to 6, this line is your model. You don't care about it. Use the group mean to replace your prediction. So this, your regression line is not this one, but this is the line. And for this is your line. For this is your model. For this is the model. For this is your model. So this step function is your model. This is called the bin scatter approach. Okay, you divide X into different group and calculate the average of Y within each group, and that is your model. You tell me your primary school education, this is my prediction. You tell me your this is your prediction. This is the bin scatter. Why this is called non-parametric? Because we don't estimate a fixed line. Okay, because when you draw a line there, you are actually estimate 2 things, right? The slope and the intercept. There's 2 numbers to estimate. For this one, nothing to estimate. There's nothing. We are not estimating anything. Okay? Just different group and different levels. Clear? So the simplest you can do, right? But you never learn it in the college, but this is the easiest thing you can imagine, right? It's the simplest model. And probably you ask why you didn't learn it in college, right? So simple, right? Is it we are going to cheat you in the college? No. The reason is this requires a lot of data to work. If in general, if your data not enough, it's not good enough. This kind of method only works very well when you have a lot of data, and this worked very well. Okay. Okay. It's okay. This is the first model. Let me finish this one, and then we will have fun. Okay. So we want to find a good bargain hotel, right? We want to filter the data to 3 to 4. I mean, we know this data very well. And you know this data well because it's your assignment, right? So to focus on price below 16. So what you do is going to focus on the cases, whether you want to be in, which is 2 miles from the city or beyond 2 miles. Or you look at 0 to 1, 1 to 2, 2 to 3, and 3 beyond. Okay, this is a model. And again, NumPy, Panda, data, Dano, I'm not going to repeat. I know you know very well, right? If you don't know, you have crisis for your assignment. So this is data. I'm not going to do it. It's so simple, I think, now for the moment. This is a filter. I don't think I need it. You need the assignment as well, right? So you should don't worry. So what I'm going to do is, the new one is I have the following. I have this 2 is divided into close and far. Look at this. Is I use M.P.where. Okay. It's the same as Excel if. Okay. I look at this. If less than 2, I say close. Otherwise, I call far. Nothing new there, right? And then I change it to categorical variable because this is categorical, so I make it easier to plot things, okay? Otherwise, you don't really need it, okay? Just to make the plotting easier. And what I'm going to do, because I want to calculate mean in each group, so it's group by, right? I group by far and close, right? And then I would do the aggregate, is expect the price. I calculate each price, calculate mean, right? I'll calculate mean in each group. That's how I do the flat line. Remember, right? That's not the flat line in the graph. And I reset the index because just make sure that things look nice. There's a data. Okay. And then this is the average of close and far. So this is my model, right? If the hotel is close, this is my price. If the hotel is far, this is my model, right? The simplest model you can imagine, right? There's nothing deep there. And I can plot it. I think after this plot, I'm done. So again, our old friend, Matplotlib, PY plot, you know it for your assignment if you have done it. Then you have X and Y, scatter plot, X label, Y label, so. We do it many times already, so I don't want to bother. So this is our model. Simple enough, right? So that is our model, and then we can do the for group in the next class, I think. And here is like I'll talk about this next class. It's just like, I just want to do a subplot because I want to put a number there, okay? That's the only thing, okay? But I don't want to bother you with that, okay? So let's have fun. So it's multiple choice question. And let me check. We have 30 minutes. Okay. And then I don't allow unlimited attempt. You just do 1 attempt. Okay. Otherwise, you keep doing one level of attempt, right? So, and then yeah. So I will randomize a question. So no need to pick the others because your order for you and your friend is different. So don't copy, otherwise you'll be all wrong, okay? Okay. So to make sure that you don't cheat, I don't allow backtracking. Means that you answer the question. Okay, I allow backtracking. Okay, so. Okay. But okay. So I'm going to make available. You can do it 30 minutes. Blackboard. Go to blackboard. Make sure submit. You get 1 point. You get more than half correct, you get 3 points. Okay, you don't do anything, it's 0. So submit nothing is also 1 point.
That's multiple choice question.
Some problem.
Don't let me see use AI. So I have someone finished already. So you finish, you can leave. So to celebrate your holiday, I have some random draw over here. You can pick up something for your holiday gift. A small gift for me. Some of you ask me why I eat McDonald's because I bought this. I used up my budget. So that's the reason. So feel free to get one, and then you can, if you want to leave, you can leave earlier. Okay. But don't complain. I have less time for your class. Okay. Yeah. Thank you. Thank you. Have fun. Thank you very much. Enjoy the outcome festival. Only too much to do. Got it. Open. Thank you very much. Enjoy. Regression is over and answer that total percent. Automatic surveillance, you just have to tell you some regression. AI regression. That's special information. AI from neural network type, they lost conversion. Same thing. Mention so that they cover person can cover had it kind of the kind of machine information then was all the power. 所以我搞就是令人反映到的搞出来。History. Để đá cho phòng. Vệ sinh. Sẽ phát sinh sinh. Phát bình phán sẽ phát sinh. 人想難啲，我下次難啲咯，係唔好睇晒你啦。個 quiz 睇下我搞幾多度啦。我哋每教俾兩個 set of 嘅 slide 俾佢有一次 quiz。啊？應該至少3個嘅，至少3到4個嘅，隨便。
好啊，多謝晒。
多謝，中秋節快樂。
你都係。
我呢度你用咗我嘅 lunch budget，dinner budget 買咩？因為呢度有啲咩3嚿幾水啊？
美金
我唔知啫。平嘅，但係今晚嘅 budget 固定咗啦。
咩計啊？你一個嘅 salary 嚟㗎？
我房嘅 salary 好低，我啲工數低嘅啫。隨便啦，食下花生，啱定瞓陣，食花生睇我經，華生片嘅病，最開心嘅啦，好正嘅正。呢個會食不過食唔得好嗨。
你做咩買啲？Like rhythm spy. 我哋下次搞啲嘢 challenge， 好啊。我諗仲5分鐘點數，收幾快啊？少少嘅禮物，咁收幾快？呢個正，係啊，你個燒烤呢個係，我就係呢個啦，應該最想燒嘅，最想燒。光節快樂，光節快樂。講個大係佢同分點社會。都未有時間，因為呢個。
多謝阿 Sir。
OK。邊都冇嘢啊嘛。啲大學有減，可以。我就見，但係做咩做？
唔記得咗。 係啊，你而家咪先係咯，係得啦，係咁樣嘅。
教你個科先啦。拜，中秋節快樂啊！
中秋節快樂，中秋節快樂，中秋節快樂。你叫咯，係嘛？
嗱，呢度
呢度有啦，150分啦，得咯，得啦，得噶啦，有噶啦。啊。
即係話要翻
有陣時即係話我個 data 喺邊度？Where the center of data？ That's what it is. The central value data point process。個 data 喺邊度？中間 center tendency 就係 mean median mode。
OK，因為
嗰時你嗰啲喺邊度？你答啱超過一半就滿分㗎啦，唔緊要。我哋問你想問我答多你一題。
失眠嘅，如果我諗唔，
但係我而家俾你聽就係超過答案超過一半你就100。係我咯。誒，緊要，你知道我哋係 absolute grading。我幫唔到你啊！唔開心食多少少啦。係啊，你翻睇身啊！有啲你哋主要當你哋多啲分，已經本身㗎，我啲再多啦。我中意話中意就翻就中意翻啦。打風啊！應該好啦，你希望你哋安安心心過中秋啦。
佢先睇嘅。
講，隨便。
你諗咗好多啊！
你問你中意啲咩先？仲要問？
得嘅。
如果我覺得有趣，對你同學有趣，咪7咯，係嘛？
呢個我哋
我睇7，我意思係話你唔係就係我噶嘛，你啲 friend 都會俾分噶嘛。我食咗佢啦。
冇寫落去嘅，我哋有最分嗰個，我哋圍咗一個。我有寫到個，係啊，係呢個啊。咦？呢個邊度嚟？我嚟嘅啫。係。
你覺得有啲咩？你啲同學會覺得好有趣嘅？除咗我之外，唔係淨係我噶嘛？都得，7或者12都 OK 啊。
7、12咯。
嗰度都 OK 啊。
唔係7係好正經嘅嗰種。我哋其實我都有興趣12咯。
係咁，你有12啊，或者係都 OK 嘅。咁誒，你同事有咩？有啲同學有啲咩意見啊嘛？係咪先？我哋係呢啲有興趣咯。即係11都得嘅，我11，我諗11都會大家都 OK 嘅。但係我覺得7同12係一個比較大家會最有興趣嘅。好，當然4可能都得嘅。4都 OK。嚇？4
我哋就話即係嗰啲分啲比出冇咁悶。係啊。
咁冇咁悶㗎嘛？呢個幾有趣㗎嘛？呢都有趣㗎嘛？
好。OK。
但係我未睇到你仔細問嗰個問題咧，就係 big topic 就係咁啦。第一個問題我唔知得唔知。如果唔怕啦，你 AI 佢問下得㗎。我唔係我即係你問我意見，我之後佢聽呢個大 topic 㗎嘛，我但係唔知你 detail 係咩啊嘛。
先啦，我哋讀嘅4係呢個啦，
呢個都 OK，呢個幾 OK，呢個幾 OK，頭先我睇幾 OK。
7呢個啦
，7都幾 OK 啊，7都幾大家都好有興趣我諗。12我覺得係，我見到啦就係嗰個啦，就係嗰個，就係頭先嗰個啦。
係搬咗。
你做呢啲嘅興趣咧，你都幾犀利啊！
我哋一齊做㗎，係啊。呢個我哋
你可唔可以演員？你幾犀利？
係啊，幾好啊，幾好啊！data 你都有啦，OK 咯。 呢頭都多啦，上嗰啲 M 咪上嗰啲 M 咪大打啦，大堆。
但是大會最好而家運動快。
得，你上去呢頭就得。不過你隨便喺個 Facebook 度咁，每人嘅 Facebook 度抓啲人咪搞掂啦。
我哋本身諗住話整呢個嘅話俾大家入下你哋啲料，跟住睇你哋可唔可以 match 到。因為我而家得2分鐘一個人應該。
哇！你呢個起碼搞個鐘。
你哋自己 download。
係啊，都。
可以係電波咧。
係都寫。
哦，都得啊！你我哋有一堂，因為我哋好零。
想大家可以早啲放學啫，係咪先？
我哋上一堂俾的得咯，13號俾。其實我哋係諗住邊一個 course 嘅 project 同邊一個？
記得你哋可以同一份嘢交2個地方嘅。
其實如果
一個 data 可以，但係唔可以同一篇嘢交2個地方，咁會俾人。
呢個可以去可以另一個 course 或者我哋將係啊，總之佢有我哋上堂係啊，OK 啊，先睇下呢3個咯。唔該晒。
哇！